Okay, so like in this stream, we're gonna try to look at impossibility results for like small neural nets. So in other words, like, are there specific training sets that a in this case, like a zero hidden layer neural net cannot learn. So it's kind of like it's prefatory to like generalization. So yeah, let me just yeah, so like let's look at my cool graphic here. So we have like a neural net taking points in two-dimensional space, aka R2. Although I mean, like it's on a computer, so like it's an approximation. It's R2. So but anyway, so like this is like a grid of points in R2, and so what's happening is I should just play the animation. Oh, that's cool. So what's happening is we have red squares, and that's indicating that the point is in the training set, and that is an input point, and we want the neural net to map this input point to this input point. And so in particular, we have different colors. So like, right? So like that's what. So we're saying like this green square, we want it to map over to here, and this blue square we want it to map over to the blue circle, and the red square goes to the red circle, and the yellow square goes to the yellow circle. And so then we're trying to figure out like, are there training, or like, can you characterize the training sets? Like, is there some like way to characterize training sets that are not possible to learn? So for instance, I mean, like, it seems like this is a good example perhaps of one, because it seems like yeah, because like so like I was motivated by this question, by like the idea of like the capacity of a neural net, because I was trying to like train a text predictor, and like I was mapping individual phrases to like floating point vectors, and then the floating point vector, the neural net was supposed to predict the next character, and like the characters were represented as floating point vectors as well. So for like to memorize the training set, the neural net like basically had to memorize these mappings between like high-dimensional floating point vectors. And so then like it wasn't memorizing them, like it wasn't even getting the training data, memorizing the training set. And so then I was like, what about the capacity, like, you know, like in general, how many pairs could like a neural net memorize? And then it kind of becomes apparent that it's like it depends on like specifically what the training set is. Because for instance, like if the training set is just like the identity function, then, you know, like presumably like a single hidden layer could presumably memorize an arbitrarily large number of pairs, whereas if the training set is something like this, then it can't quite, like it just doesn't seem like it can possibly fit this particular training set but maybe it can. So like these are like different weight initializations for the same training set. And yeah, it seems to continue, it seems to hit the same problem all the time, which is that like the red square wants to go up and like the yellow square wants to go down. And so like it can't do that. But I think it's like one thing, so like one conjecture we feel kind of good about is if your training set is size 1, meaning you have just one, right? So like we have this red square and we want it to output here, you know, which is the same as just like an arbitrary association between like two-dimensional points. So when we train this, it can pretty much get it, like from any kind of initialization. Oh, you know what? I should probably reset the optimizer. Yeah. I'm going to ignore that though. Right, so like every time it gets it, and then like if we do a different training pair, it'll probably get it again. Right, so it seems like conjecturally, you know, size 1 training set, it'll always work. Also, I am going to do an aside here, because I would like to have a border, so this is like more centered, and so I'm going to see if I can accomplish that. I'm using the Copilot plugin, so I'm going to see if it will let me do that. So create a div for the app elements so that they will be centered on the page. Is this going to work? App div style display flex, justify content center, align items center. Huh. And then I need to add it to canvases. Yeah. Okay, let me see. Active. Pen child active. And then I think I just want to add everything to the active. So maybe if I do this, active, is that gonna work? No, it did not. It broke everything. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Whoa. Okay. Yeah, but like it's... Okay, it is kind of centered. And, canvas, active. Okay, and then I just need to add the buttons as well. Ooh, that's not what I wanted. Okay. Yeah, I mean, I just wanted to get it off the top. That's fine. That's fine. Okay. So anyway, back to like doing like pretty hardcore theorization here. So yeah, like single instance training set seems like it always works. Maybe. Yeah, because you have instances like this where it's like, it seems like the other points like are in the way. And yeah, so it doesn't want to fit the other points. So it seems like, yeah, I don't know, you can get crowded out by the other points maybe? I don't know. But like this should easily work. Yeah. Okay, so let's go to two. Let's go to two training examples. Or training set of size 2. Right, so we now are trying to match the red square with the red circle and the green square with the green circle. It's like no problem. No problem. Kind of. So, try this one. And also, it's like no problem. So it's like, are we prepared to conjecture that like any training set of size 2, the neuronal network of, also I should just show you my like neural net if I can find it. Where is it? Huh. Yeah, but like, where is it? Yeah. Right? This is the whole thing. So 2 inputs, 2 outputs, 10H, good to go. Also, the other observation to note here is, like, if we keep the same training set, right, like, these other points are, you know, like, just the input grid being, like, transformed by the neural net. And so, like, for different, like, random initializations, the neural net will, like, position that grid differently, which, you know, like, corresponds to kind of, like, different, like, if you're interpreting the neural net as, like, a inferential object, it's creating different inferences, like, you know, for, like, where is this point supposed to be based on my training set, right? Like, it ends up at different places, right? Like, this time it's like, oh, it's a line, everything is a line, right? That's weird, because, like, if we start it here, it doesn't end up as a line. So, like, it's making different inferences, like, every time. But okay, let's look at a few more, like, two-dimensional training sets, or no, training sets with two pairs, two training pairs, two items. Training sets with two items in them. I mean, it does it every time. See, like, this is a different inference. This is a different thing. That one's weird. Can I style my buttons? This again is a sidetrack, but it's like, I never really learned CSS, but now that I have Copilot, I can kind of, like, you know, style stuff. How should I style it? Style. The button to look like a play pause button. Yeah, sure. What does that do? Is that gonna do it? That's, for some reason, it's sleeping on me. Okay, so that we'll just ignore that for now, since it doesn't matter. Okay, this training set should be easy, right? Yeah. What about if, yeah, I mean, I can't really think of, like, a training set that would be hard to do. I mean, yeah. So, but, like, if that's true, it's saying, like, you know, any neural net with two inputs and two outputs, no hidden layer, has a capacity of, like, 2 for any two training sets, for any training sets of size 2. Is that true? Okay, let's go to 3. Oh man, I got spams. How do you kill spams? Hide user. Yeah. Okay, so gonna do size 3. There's also kind of like an issue of like, you know, like it has to stretch for this one, but like, does that count? I mean, I don't know. Okay, do a different one. I mean, I guess that works. Do a different one. Ooh, this one might be hard. Maybe? Also, I should say, it seems statistically that, like, I keep getting, like, target points that are, like, on the border. That, like, that shouldn't be... That seems statistically unlikely. Or, like, probabilistically unlikely. Unless I have a bug. Okay, this one doesn't seem to be, okay, let's try a different initial condition. Whoa. It's like, why does it want to put the green square down here? This might be an example of one that's not learnable, because, like with 0 hidden layers. Because, like, it wants to push the things out, and then, but the green one doesn't want to go out so far. Let's try one more initial condition here. Yeah, like it seems like it keeps putting the green one too far down. That might be a thing. That might be a thing. Although, like, that's just a triangle? Huh. You see, like, I always get one of the targets on the very top or bottom. Like, that's over there. Okay, there we go. Okay, is it gonna fit this one? Yeah, pretty easily. Pretty easily. What about this one? Whoa. Yeah. I would say it fitted that one pretty easily. Okay, let's go to 5. Or should we go to 4 first? Yeah, let's go to 4. Okay. Okay, so training size 4. See, we now have a yellow target. Okay, it's like yellow is going here, blue is going here, red is going here, green is going there. It's not working. Try again. Ooh. Huh. Maybe this one's not possible. I mean, you'd think at some point, you know, like, you would hit a training set that isn't actually possible. So, well, with 0 hidden layers. Trying to figure out like if I want to add another hidden layer. So it looks like this one is not possible, and but like, is that interesting? Like, probably not. But like, let's see. Can we try to figure out why it's not possible? Like, because so like, why is this yellow not showing up over here? Well, it just seems like it can't fit it. Let's try another one. So it's kind of, I mean, it's kind of looking like any size 4 training set is not possible. So it's, yeah, I mean, like basically all of these seem like they're not possible. So, I think what I'm gonna do now is I'm gonna try to add like another layer in its visualization, and then see like if it's then possible to fit training sets of size 4. So we'll just do that real fast, theoretically. Okay, so I need to go to the neural net and add another layer. And no. So I need to say dot wow, it knew what I was doing after a while. Do I have to say const? Okay. Inputs. No, I think you just want it to be neural net inputs. Isn't it? What does it matter? Yeah, okay. Okay, so we have layer 1 and layer 2, and then we want to say layer 1 outputs is layer 1.predict, and let's make sure everything still works. Actually, the animation needs to be different also. Where's the animation loop? Still works. Okay, then we need to add another canvas for layer 2. Should probably factor this into like its own function and everything, but okay, so that should show 3 canvases. Nice. Okay. And then we need to update the animation loop also. Ooh, this is the thing. Okay, that should like work. And it seems like it's not go. It kind of fit. You know what? I would count that. I would count that as fitting. Like this. Okay, so like do a different training set. Seems like it did it. Seems like it did it. It's also kind of weird. You can see like the layer 1 like isn't remotely right. Like this guy is supposed to be down here. This one is supposed to be over here. This one is right. Like it's not approximating the solution at all. It seems like. Although also this isn't quite the solution because the blue is not lined up. This might be one I can't fit because it really wants to put the blue over here.